So this is the report back from the fourth group on agricultural global monitoring modelling. Pierre had to leave yesterday, and he and I sat down for half an hour and kind of joined our thoughts. So this is from both of us. So these were the topic areas that were covered by the talks and the posters. The usual list of things that we're interested in, from forecasting, and then the inputs of crop type and area, crop condition, and then yield modelling, including irrigated areas that we saw, and then agricultural land use change monitoring, again showing that it's a dynamic system. And then improving the national monitoring methods using Earth observations, field data collection methods, radiative transfer modelling approaches, including the incorporation of diffuse radiation, which is something I think we were pleased to see. The multi-source, multi-resolution data analysis that we were presented on, and then the observation requirements. So that's the range of stuff that was in this meeting, and I think it gives a flavour for where the community is at. So we made an observation about the crop modelling yield estimation. The way we view it is there are currently three scales of study. There is the modelling at the field scale, which is extremely well parameterized models. Using those models, the remote sensing at that field scale is very well developed indeed. There are groups not too far from this building where I've spent most of their last several decades working on this, and I think it's well developed. It has strong application to management and precision agriculture, of course, and carbon water fluxes can even be taken out of those systems, derived from those systems. So that's the first group of models, class of models. The second is the modelling at the landscape scale, emphasis on parameterization by weather data, meteor parameterization, and with potential linkages to climate models, so that we can go into the future and change the sort of humidity and rainfall and temperature, and get some estimate of what's going to be happening in terms of the production in the future. And there's a whole program called AgMIP, which some of you are involved in. I know our colleagues at Wageningen are very much involved in that, to do intercomparison between these models. So if you remember, when we first started the GV2M work, there were model intercomparison. There was PILPS, and before PILPS there was ISOSCIP, and then the model intercomparison done. And I think we're going through the same process now for the ag models, a little bit behind the DGVMs, which is characteristic of the whole of this field of agricultural remote sensing. AgMIP is more associated with these non-remote sensing models. So then the next area is regional national scale yield estimation models. Those are the ones that are trying to come up with national scale estimates of production. And really there's a strong integration of remote sensing in those. These are in development. We have regression models, you've seen those. And we have some blending now of additional information, not just remotely sensed derived data. So those are the three scales of model that we've seen at this meeting. There are, of course, agricultural land use models and land use change models, but again, with the land cover group, we didn't really see those those future models of land use, but that's a whole other thing that we haven't really touched on at this meeting. So in terms of research priorities as we see them, obviously we need better baseline data sets. You can see that, cropping systems, distribution, crop calendars, irrigation, distribution, all of that stuff. The baseline data sets which we're going to be using for these more global scale implementation. A better understanding of the variables that can be consistently retrieved by remote sensing through intensive measurements and phenotyping. That's something that I think is really taking off here. We need to develop models which can capitalize on multiple inputs of surrogates in terms of biophysical and meteorological measurements, and we've seen a little bit of that in the presentations. Rather than assuming that the models are really going to be working in data-poor environment, they have to stand alone. So I think we're getting much more sophisticated at extracting information from the satellite data that we need for driving these models in terms of biophysics. Develop models suitable for application at the regional scales, which address spatial diversity of landscapes and cropping systems. This is what was something that we noticed quite clearly in the development of the land cover work, is that when we were starting out, we got a lot of emphasis on forest cover change for obvious reasons, and all the other land cover classes seemed to be pretty good, except when you got into cropland areas, and that was the sort of the bin where everybody throws everything and says mixed, cropland mixed. And so we're really honing in on that aspect of it. And we've got to think more carefully about diversity of landscapes and cropping systems. We heard about data assimilation, as Fred said. There were some efforts at that before, and I guess, you know, when we're looking at how science evolves, there's always some sort of early push, the pioneers, as we heard earlier, or the early adopters, and then what happens is it's ahead of its time a little bit, and then everybody drops it. Then 5-10 years later it comes back, and that's what we're seeing, I think, in terms of data assimilation discussion from that community. We need robust, generally applicable models that are needed for the operational application. Let's go to field data collection methods in support of crop monitoring and modeling. Multiple data collection initiatives around the world for agricultural sites. We've known that for many years. Agronomists have focus sites where they're collecting and doing very detailed measurements. The idea is that there are a number of diverse sampling, measurement instruments, frequency of observations, and all of that prevents the data modeling into comparisons between the intensive field sites. And really that's where AgNIP is coming from in terms of trying to focus on some well-documented sites. We're doing the same for JCAM. I think next year we're going to have a meeting of the minds on that, given the fact that remote sensing has not been an integral part of AgNIP to date, and we're both working on different test sites. And I think it's a chance to come together and combine the remote sensing and the modeling a little bit better. Everybody agrees, it's just that nobody has the time, and there really isn't a lot of funding for these big international programs yet. Priority standardization needed on the minimum set of critical variables and the associated data quality reporting. We need to assure that data collection protocols are in place for the upcoming satellite missions. You know, we've got soil moisture and biomass, and we really need to get ahead of the game with the land product validation working group of CEOS and make sure that we get the data collection protocols and the accuracy assessment methods integral to these missions. Explore the utilization of UAVs. This is something for the agricultural community that's taking us off, particularly in the commercial sector, associated more with precision ag. But I think we've got an opportunity with those sensing systems available to use them to complement our field data and to address the issues of scaling up. Remote sense variables in support of crop monitoring and modeling. I have to be careful what I say because I'm going to lose some friends, but the long-lasting NDVI success seems to hamper further innovative approaches. That was the way we put it with Pierre and myself. And I think that's true. I think we got something simple and useful, and people say, well, why didn't you use anything else? But there's been a huge cottage industry of people generating variables, and many versions of the same thing. How many FAPAR products are there? How many alternative VIs are there, from Savvy to Savi to Gemmy, and you know, it keeps going and going and going. So we've got this cottage industry, and we really need to be a little bit more mature in terms of our community, particularly when we're asking other communities to use these data and they don't know what to use, when and where, and whether should they use the EVI or you know, this kind of stuff. And it really, we need to move beyond that. So the actual biophysical, physiological interpretation consistency of retrieved variables from remote sensing requires more attention. We're still, although a lot of effort's being put into these areas, I think we've just got to sort of nail that down and get to a point where we sort of end and then continue the next phase of research. But I think the consistency is important. So priorities that we saw: accuracy assessment must be explicit for all products, obvious. Community consensus needed for what we're calling essential agricultural variables. This is not climate variables, but you know, it's the same kind of concept, that it would be better if the community were working on one or two things rather than 5 different groups developing variables and nobody knows, and then we have to work on how they fit together or what the relationship is and which one you should use in which system, and you know, I think it's messy. So community consensus. After you've done this open period of development and creativity, we need to get to something on best practices and methods. So more emphasis needed on SAR algorithms and products for agriculture. There's some nice work going on in Canada that some of us have seen, other people are ignoring it. We're looking at SAR, of course, for rice production, but I think there's also application, as we saw from one of the presentations, about different times of the growing season. We can use that. And explore smart use of daily observations rather than temporal composites, which kind of smooth out a lot of the information. Multi-source, multi-resolution data. Emphasis to date remains on single systems, single class of systems. We need to move from missions to measurements. NASA was going to do missions to measurements, which everybody thought was a great idea. Some people were getting a bit nervous what that meant, but I really felt that that's the way we should go. And when you think about the ECVs, we should really be talking about using all of the assets that are out there to develop the best possible climate variable, rather than, well, I'm only allowed to use this sensor because the space agency is paying for it. So we need to move from missions to measurements. I think the sooner we do that, the stronger we'll be. Priorities, this is not new. We've seen these priorities 5 years ago. Fusion, coarse, moderate, microwave optical. Let's not spend time talking about that. Observation requirements. This is something where I think we've been at a disadvantage for the agricultural community. We need a coordinated acquisition of data among instruments and agencies to finally realize the full potential. I actually think we've got the instruments up there now which could do the job. We just can't get them to work together in a coordinated, concerted effort. So that's what we've been trying for. Long-term strategy. This is not just a demonstration of what remote sensing could do. This is, okay, let's get serious and start to make this happen all the time. High temporal frequency is obvious and near real time. So won't talk too much about the program. We've seen this, but it's a bottom-up initiative. We know who the target audience is, and they're engaged, and we're trying to make that better linkage to economics and policy, because that's going to justify the sort of resources that we're looking for. Emphasis on data sharing, of course. Focus on operational R&D, opportunities for site-level work, and I'd like to see that grow. National capacity building, both in developing and developed countries. It's not a developing country issue. It's capacity for agricultural agencies to utilize the EO that's up there. And then the last point is Michelle is sitting over on the side. Michelle, do you want to put your hand up and stand up or something? He's going to be the new lead. He's the new lead, just been in a couple of months. So if you want to get involved, talk to Michelle. So we've created a new opportunity for a new focus on improving agricultural monitoring using Earth observation. Back to the future, as I was talking about AgriStars. Maybe an international AgriStars is the way to put it, but given the fact that program failed, I'm not sure we want to tie ourselves to that. The world's food problems are not going away. Looking at the amount of food I've eaten this week, I'm doing my fair share at creating that problem. So. GeoGlam is an umbrella organization, provides opportunity and policy rationale for you to go and seek support at the national level. These international programs never have any money. All the money's at the national level, but you can use these programs to secure funding for your own initiatives within the framework of that umbrella program. Challenges remain in terms of research and operations. So Fred said recommendations to space agencies. So we've done that. First one is better coordination of that 10 to 30 meter class of observation. To this end, this is the point that I'd like to say in any report that goes out, that global acquisition and open data policy to all from the Sentinel-2 sensors will be critical. And then we can start to put pressure on India and China to do the same. But I think we need to hold the Commission to its word on this, that we're going to have access to data, then we can all move forward. So that would be extremely important, actually critical to the program. Next one is near real-time, ready-to-use data. I said near real-time because ag stuff changes. If you get it next week, it's not very useful. Ready-to-use is Pierre's word, because he thinks that just delivering data to people doesn't really help. We have to get it so that it's in a way that people can use it. Then the next one is quite easy. It's the microwave, and including the coherence data of the value regions, and I think this is where we should push. I think that's something that could really pay off. That's it, thank you. So any other comments? Any other comments? I think Greg, you had one.
Yeah, but at the end you mentioned pretty much. Well, no, yeah. Just a small comment about, well, I was thinking that maybe also there was not perhaps enough people here from the the crop modeling community, in the sense that we have many people on GVMs, but from the crop modeling itself, there's plenty of people doing a lot of stuff, and who might be interested to involve them in the future. I'm saying that because from what I've seen with ACMIP, and this I think Chris mentioned it, that they're trying to do inter-comparisons models over the whole of the planet pretty much, and I think it lacks some grounding to satellite observation, in situ measurements and things like that, which I'm glad that the GVMs are doing, but in the crop modeling it's perhaps still not so integrated. So it would be good to have them perhaps on board a bit more next time.
As I say, I put that point at the bottom of the summary, that they weren't really here. Anything else?
Is there a reason why we didn't reach them?
Because the title of the workshop is Global Vegetation Monitoring and Modelling.
Yeah.
They're really not global at all. They're very much local.
Well, the ACMIPs are global.
There is a global component to it,
Yeah.
but most of the focus is at the site level into comparison at this point.
Yeah.
So I say a meeting with ACMIP next year might be a good idea. Or we could invite them to the next one of these workshops.
A short comment concerning the data policy for the Sentinel missions. Let me assure you, we do have a free and open data policy in place already. So the recommendation is probably obsolete. Let's put it this way.
I don't think so. I'm expected to differ, and I feel very strongly about this. The data policy is one thing. Can you get the data is another one. Are they acquiring the data is another one. So it's not just the policy. The policy can be free and open. But when you go and try and get the data, you can't get it for multiple reasons, or it just wasn't acquired. Or you have to fill out a form, and you can only download 1 or 2 scenes at a time. You know, we've got to move to a point where it's free and open, and the pipe's there, and you can just suck it all in. You saw some of the presentations using 4,000 Landsat scenes. We've got to be able to do that if we're going to work on this kind of stuff. And I think it's, you know, the time has come, and I really hope that it works. So data policy is okay, and I think that's wonderful, truly wonderful. But it's more than that.
I fully agree, but then you should reformulate your recommendation. Then it's wrongly formulated. And
let's reformulate.
Let me also tell you that actually redistribution is a part. Free redistribution of the data is a part of the data policy. So anybody who is actually getting the data can redistribute the data. This is an important aspect. Furthermore, in the Copernicus program, we do have what we call collaborative ground segments. So if you really need the data and you face some problems because of the bandwidth and you can't get all the data, then you may consider a collaborative ground segment to receive the data.
Yeah, but how are you going to know they've got it?
You set it up yourself.
Okay, so the devil's in the detail. So actually, and I'm happy to go mano a mano about this because I feel quite rabid about it this morning. At least I just had 3 coffees, so I'm ready to go. This says, to this end, the global acquisition. Because when I first spoke to Sentinels, they said they're going to collect everything, everywhere, all the time. They don't need an acquisition strategy. If they're collecting everything, everywhere, all the time, then global acquisition, that's that. Open data policy will be critical. So we're not saying it will be critical to our program. We're saying very good, thank you very much. But we're making the point that it's absolutely critical that happens.
I think it's very good to pinpoint that because recently there was a call for a proposal by the European Space Agency regarding the validation of Sentinel-2 products. And actually, the aim of the call was just to deliver Sentinel-2 data, but not to fund the validation. So I think that's a bit strange. Because I was thinking that Sentinel-2 data were freely available, but actually you need to get to this call for opportunity to get, even for the validation, that's some kind of, okay.
And there's also some rumours floating around, so let's try and not bring rumours up. But the context is that although it's stated now, it's going to be revisited. This open policy will be revisited because European industry is concerned. So I don't know. I mean, let's keep going and just we're all all of the presentations, or a lot of presentations, talk about when Sentinel comes, we're going to be really in good shape. So let's please hope that happens, and I think we have to keep the focus on. And it's important, really important, and I think you'll have so many users of the data if people could get it.
So I think we